I went through your test this morning. This is geometry. This is getting ready for your 1 through 30 test tomorrow. And I looked at the questions, and I tried to find questions from either one of the reviews that was a close enough approximation to what you're going to see on the test. Okay, so what we would find that's going to match question number 1 on the test, closest on some of these things, is going to be like question number 6 here. Now the difference is that the question number 1 on the test is algebraic. So they're going to tell you that there's a point on the line between 2 points, and they're going to give you the algebraic approximation. So let's say we had, and they're going to write all this out. They're not going to draw you the picture. So let's say we know this is D and this is F, and somewhere in the middle, somewhere in between is E. Now, I'm purposing to not put E in the middle so that you're not thinking that it's a midpoint. But if I got something along the lines of, let's say I knew that DE was 10x minus 10, and I knew that EF was along the lines of 6x plus 4. And the question came down to me, what is DF? Right? I think we saw this on your last test, correct? So basically all we're going to do is we're going to add those together, right? And you add them, right? Because we're looking for this. All right, so if I add them together, I'm going to get the whole length. It's like saying I know how far it is from here to Green City. I know how far it is from Green City to Kirksville. Question is how far is it from here to Kirksville? Does that make sense? So you add the two distances together, the two known distances. So with something like this, I would get 16x minus 6. Okay, does that make sense? Okay, so that's what we're going to see. Question number 6, like I said, is somewhat like it, but you'll notice that there are some differences in the fact that it's not telling you, it's not giving it to you in algebraic terms. It's just giving you straight numbers. All right, so they're asking point y lies on xz between x and z, xy. Okay, that would be like what we see here. Oh, sorry, erased it. That'd be like what you see here, and xy. Okay, except in that question they give you that whole length, and they're going to ask you what is this length here. So it's a little different. That's why I'm trying to give you not only one to look at that's from the same lesson type, but also an example question that looks a little bit more closer to what's on the test. Does that make sense? Yeah, you're going to subtract. So you're going to end up taking 15 minus 2. YZ should be 13, I think. Okay. All right, question number 2 on the test is similar to what we see with question number, let's see, look at a couple of these things here, which I got both of these up. Question 15. All right, it says how many units is the perimeter of a rectangle if it has a length of 7 and a width of 4? Right, that should be pretty easy to do. 7 plus 7 plus 4 plus 4, 14 plus 8. Right, should give you something like 22. What's troublesome about perimeter is that a lot of people don't read it closely, and they automatically take 7 times 4 and get 28. 28 would be one of the options that would be on the test. Right, so you have to make sure that you are slowing down to the point that you recognize the difference between perimeter and area. Okay, because you're going to feel real silly come the day after the test and see which questions you missed and find out that you did area instead of perimeter or perimeter instead of area. Does that make sense? Now, I will tell you on the test, it won't necessarily be a rectangle. Okay, so you're going to have to know your perimeter properties of quadrilaterals. Okay, so it might be a square, it could be a rhombus, it could be a trapezoid. You need to be able to find the perimeters of any one of those types of figures. Does that make sense? With a rhombus, okay, so in a rhombus, all 4 sides are congruent. So if I knew what one side was, I would just take it times 4. Same way with a square. Rectangle is 2L plus 2W. Okay. Same way with, like, if I just knew it was a parallelogram. Okay. All right. We feel pretty good about that. Okay. Let's see. The next question. See, I'm going to come down to like number 22, number 23. Of course, you can tell from here that we're using the distance formula. Okay? Now, what I want you to be aware of is that it's very possible that you're going to get a radical answer. Okay, do we know what I mean by that? Yeah, not mean like a really cool answer or a really amazing answer from the 80s. Okay, but an answer that is a square root. Okay, do we want to work out one of these? Okay, just so we're familiar. Okay, the distance formula is the square root of x1 minus x2 squared plus y sub 1 minus y sub 2 squared. So whenever I go into here, which one do you want to work out? Do you want to work out 22 or 23? 23? 23. All right, so I'm looking for my x's. All right, so I'm going to go 1 minus 9. Okay, now I'm going to go with my y's, but I got to keep, if I did x1 first, I'm going to have to do y1 first. So that's going to be negative 12 minus negative 6 squared. 1 minus 9 is negative 8, right? Negative 8 squared is 64. All right, negative 8 squared is 64. Negative 12 minus negative 6 is negative 12 plus 6, which is negative 6, and negative 6 squared is 36. Does that make sense? I went through that really quickly. Do you need to see that step by step? No? All right, 64 plus 36 is 100. All right, so if that was something that couldn't reduce, I would try to reduce it. This one, in fact, does reduce because the square root of 100 is 10. Okay, can we do that? All right, so you might need to write down your distance formula somewhere. You know that you're going to need it on this test. Okay, all right, so that gets us through question number 3. All right, question number 4. Number 4 is fairly similar to kind of like number 1 that we saw. Let's see if I got one here that looks like it. I want to say number 9 is closest to it. Okay. Let's see, number 9. Again, we would have to draw a picture. Point F lies on EG. Between E and G, EF is 2. EG is 14. Find FG. So I'll work this one out, and then I'll try to make an example that looks a little bit similar, more similar to one on the test. Okay, so I've got E, F, and G. Does that make sense? Could we draw that if we needed to? Okay. EF is 2. EG is this whole length here is 14. Find FG. All I do is subtract, right? So I should get 12 for my answer. Okay, now the difference between what you see on the test and what we see here is one, on the test it's going to be a little bit more algebraic. I'll try to make a similar one. Let's call this, we'll split it a little differently. Let's call this 12x plus 20. Call this 70. And let's call this 16x. And the question is going to be is, what is EG? Find EG. All right, so I should know off the bat that I am going to solve for x, but I'm going to have to plug x back into 16x. Okay, now what I do know is that 12x plus 20 plus 70 equals what? Equals 16x. I'm still using the segment addition postulate, right? Combine like terms. What's 20 and 70? So I got 12x plus 90 equals 16x. I'm going to subtract, good, 12x. Okay, 90 equals, what's 16 minus 12? So I got 4x. I'm going to take 90 divided by 4. All right, so I'm getting x equals 22.5, and that would be an answer on the test, but it's going to be the wrong answer because I haven't answered the question it's asked. What do I have to do with that 22.5? Plug it in for 16x. Okay, so 16 times 22.5, 360. Okay, that's my answer. Okay, and that's the difference between getting it right and getting it wrong, is that you can do all the right math and see the segment addition postulate and solve for x and still be wrong. So it didn't answer the question it was asked. No, you won't have to have a label on that. Okay, because it doesn't give you any kind of measurement. Okay. All right. Let's see, number 5. Let's look at number 14. And this is actually pretty close. I actually won't even try to give you a different type of question. It says, look at the progression of the pattern below and formulate a conjecture regarding the number of squares that will be in the 5th step of this pattern. That's pretty similar to what you're looking at on the test. It's a little bit different looking, but one of the things I want you to notice is I'm going to find a pattern here. So like figure 1, if I need to, I could create a table. Sometimes that's an easier way to see a pattern. So figure 1 has 1 square. Figure 2 has 4 squares. Figure 3 has 9 squares. We want, right, so we should get 16 and 25 because it's the figure number squared, right? And I can see that. I can actually go ahead and test that. Notice that this has 1 in the middle, this has 2 in the middle, this has 3 in the middle. So if I wanted to test this, how many boxes would I have in the middle? No, because we want the 5th figure, right? I don't have to go to just the 4th and then the 5th. One, let's see. Right, I can start with that. Okay. Right, and in the end, I can count and see if I'm right. All right, are there 25 boxes there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so when in doubt, go so far as to actually draw the picture. See if it works. Okay. All right, that's number 5. Let's see, number 6. Let's see, let's come down here. There's actually several that are going to look like this. Let's see, question number 30 on this review, question number 16, and question number 29. More so maybe question number 30. What you're going to get out of this is a Pythagorean theorem question where they're going to ask you to find the hypotenuse. If you'll notice on question 29, a right triangle has a hypotenuse and a leg. We want to find the other leg, but we should be familiar with this enough that, and they're actually going to give you a picture to look at. So do we need to spend a lot of time going over the Pythagorean theorem? All right, because they're actually going to give you the easiest form of that type of question to find that missing length.
We're going to have the A and B.
Yeah, you're going to be given the A and B, and you're going to be asked to find the C, right? I probably should have given you something a little more challenging, like even like a 29 or something like that, but you got to, it's fine, okay. All right, so we should be pretty good with this. Just so that you're aware, in the 2 reviews that I sent you, this document here is the one that is 1 through 30, not 1-30. Do we see the difference in the ones that were sent to you? This one I think has like 50 questions. The other one only has 20. The one with 50 questions is actually a little bit better review. Okay, so I just don't remember which one is A and which one is B. But the one with 50 questions is the one we're spending the most time looking at. Is it B? So review B is probably your better review on this. Okay. Number 7, I actually didn't find a good question for number 7 in either review, but it is similar to questions we've already looked at. The only difference is that it's actually giving you a midpoint. What do we know about a midpoint? Divides that into 2 congruent pieces, right? So they're going to tell you that we've got a midpoint. They're going to tell you something like, oh, let's see, that this, and they're not going to draw a picture for you. You're going to have to draw this picture but this would come out to something like 12x. And that, let's see, that the other part's going to come out to like something like this. And they want you to find all of the individual lengths. They want to know what is AB, what is BC, what is AC. Okay? What can we do to start with this? Set them equal to each other. So 12x equals 6x plus 18. Chandler, what would you do from there? Subtract 6x from both sides. Okay, what does that give you? 6x equals 18. Then what, Maddie? What would you do after that? Divide by 6 on both sides. X equals what? You should be able to do 18 divided by 6, right? 6 times what equals 18? 3. All right, so x equals 3, but we do have to go a step beyond that, right, Jordan? What do we have to do after I know x equals 3? All right, so what's 12 times 3? 36. Okay, good. So AB is 36. BC is a little bit tougher one. Jose, do you know what 6 times 3 is? Okay, so then I get 18 and 18, right? And I should have already known what BC was going to be the moment I knew what AB was, right? Because if B is the midpoint, I know that those two are going to be equal to each other, which means AC is what? AC. 36 and 72. Okay, so I should get 36, 36, and 72. Okay? So we know what. Now, like I said, they're not going to draw the picture. They're just going to give you the information. They're going to say B is a midpoint on line AC. AB is 12x. BC is 6x plus 18. What are the lengths of AB, BC, and AC? Right? You're going to have to draw this picture. If you can't draw the picture, you're probably not going to get it right. And you have to know that a midpoint is dividing this segment into two congruent segments so that whenever I start this, I'm setting those things equal to each other. Okay? Can you guys do that? All right, I hope so. Oh gosh, what did I do with that? Did I just minimize it? Let's see. Let's get back to, here we go. This question here, you don't, because you're just looking for the area, your height of it is actually the perpendicular length 5, so it's 5 times 3 divided by 2. But we don't necessarily worried about that one. Let's see, number 7. Let's see, number 7 we just did, right? Number 8. Number 8 is going to be similar to, say, like 26, kind of. Okay, basically what they're going to do is they're going to give you two lines cut by a transversal. We have to prove that those two lines are parallel. So they might give you something like this, where they're going to say angle 1 is congruent to angle 2, and they're going to show you this is 1 and this is 2. All right, so if angle 1 is congruent to angle 2, how do I know that the two lines are parallel? Converse of the alternate exterior angles theorem. Because I'm trying to prove that the lines are parallel. Anytime I'm proving that the lines are parallel, I'm going to use the converse. So if it says prove these lines are parallel, you use the converse.
So if you already know it.
If I know that the lines are parallel already, right, then I would say, I know, let's say they said this, okay, just so you understand what's going on. If they tell me A is parallel to B, all right, then I know angle 1 is congruent to angle 2, okay? But if they tell me 1 is congruent to 2, prove A and B are parallel, then I use the converse, okay? So they could give you something like that. They could give you something like they might show you 1 and 3. Say 1 and 3 are congruent, prove that those two lines are parallel. We would use the converse of the corresponding angles postulate, right? They could tell me that 3 and 4 are congruent, right? In which case I would use the converse of the alternate interior angles theorem. 3 and 4. Okay, does that make sense? So we need to know those things from lesson 12. Okay, we're not going to be done with those. I'm going to continue to put them into tests until I'm sure that we get them and we understand them. Yup. All right. Let's see, next one down. Next one down is actually a little bit more similar to, it's from the same lesson, but it's pretty close to number 2 here. It's really close. It's different in a sense, but it's pretty darn close to number 2. So let's see, A and B, our lines A, B, and C, D are parallel. Find measure angle CLM. Okay, so it wants to know what this angle right here is. Okay. Yeah, I mean, they're different in a sense, but if you can do this question, you should be able to do the question on the test. They're going to be a little different, so don't think that this is a mirror image of it. Okay, in this case, right, because B is congruent to this angle right here, right, I should know that 4x plus 12 plus 3x plus 21 equals 180, right, because this is congruent to here, and these two things are a linear pair, right? So 4x plus 12 plus 3x plus 21, right? It's going to give me 7x plus, what, 32? I'm going to solve for x. What's that? Oh, is it 33? Oh, I'm sorry. Yep, 33. All right, we would subtract 33. Let's see, that should be, what, 147? 147 divided by 7, x equals 21. But then I'm going to plug it back into this because I also know that vertical angles are congruent, right? So if I know what angle DLK is, then I know what CLM is. Okay, so it comes out to 84. Okay, that's what I would get there. Now the question on the test, let's imagine, I'm going to try to give you something a little bit similar to what's actually on the test. Let's say that instead of 4x plus 12 being where it is, that we moved it and made that the measurement that went right here. Right? That would make those two angles alternate interior. What do we know about alternate interior angles? They're congruent. So instead of adding them up and setting them equal to 180, I would set them equal to each other, solve for x, then plug x back in. Okay? Or they might actually give you a number 4x to plug in to test and see if the lines are parallel. Yes, if you know they're congruent, if you know that the two angles are congruent, you set them equal to each other and solve. Okay? All right. All right, we're about halfway through the test. Let me see if I can give you just, you're going to need to be able to find the area of a triangle. Do we know how to do that? Okay, so I'm going to give you the numbers on here that you'd want to look at. You want to look at number 34 on the review. Yep. Number 11 on the test. Okay, they're going to give you an equation in standard form. You need to write it in slope-intercept form and then tell what the slope is and what the y-intercept is. So they could give you something like, let's say 6x plus 8y equals 40. And they'll want that in y equals mx plus b form, and then state what the slope is and then what the y-intercept is. And just so that we're aware, the number that comes in front of the x is my slope. Okay, if it's a fraction or a whole number, that's my slope. Okay, b, whatever number plus or minus comes at the end, that's my y-intercept. Are we aware of that? Okay, do we know how to convert this over to slope-intercept form? Is anybody not sure how to do that? Okay, I'm going to go ahead and tell you what the steps are so that we're clear. You're going to subtract 6x on both sides, and then you're going to divide both sides by 8, and then reduce whatever fractions you have. Okay, can we do that? Like I said, let's see, for this, number 11, number 35, number 36, under ones to look at. Number 12 on the test. They're going to give you 4 coordinates. You're going to plot those 4 coordinates on a piece of graph paper, and then you're going to state what kind of quadrilateral it is, whether it's parallelogram, rectangle, rhombus, square. Be as specific as you can in what it is, but you need to know the properties of those things to know how specific and how not specific you can be. If you look at the other review, number 3 is somewhat like this, except you don't actually have to graph those parts. As far as we can go with this, it is equiangular. I cannot say that that is equilateral. Okay? Therefore, I cannot say that it is regular. At that point, if it's not regular, it's irregular. We could call it a rectangle. We can call it a parallelogram, but that's as much as I can say about it. Okay? All right, let's go back. Let's see. Question 13. They're going to tell you about the dimensions of a trapezoid. You need to find the area of that trapezoid. So if I the review. No, that's area of a rhombus. What you want is base 1 plus base 2 times height divided by 2. Would be questions 40, okay, even 38 to a certain extent, okay, 42. All right, question number 14 actually comes from, it's going to tell you that there's an arc of a circle, has a measure of so many degrees. They're going to give you the radius, and they're going to ask for the length of the arc. This is what we just did last lesson, is arc length. Okay, arc length is 2 pi r measure in degrees over 360. Okay, can we do that? Okay, you guys just got done doing that. Okay. All right, let's see what's next. 15, you need to be able to find the area of a parallelogram. Area of a parallelogram is just length times width. Okay, or base times height. Okay, let's see, question number 16. They're going to give you the diameter of a circle. You need to find the circumference. So this would be like question 44 on your review, on this review. Okay, they're going to give you the radius of a circle. You're going to need to be able to find the area of it. Okay, that's question 46. Okay, question number 18. Question number 18 is going to give you a central angle and ask you what the intercepted arc is. This would come from question 15, what you see here. So if the central angle is a certain degree, the intercepted arc is going to be that exact same degree. So arc CD is 150 degrees. Okay, central angle and intercepted arc are always the same degrees. Okay. All right, number 19 on the test is pretty much the exact same question as number 6 on the test. Okay, so if you remember what I said about number 6, apply that same thing to number 19. And then finally, question number 20 is a proof question, but I'm going to give you a great big hint here that if you'll go into your lesson videos, into lesson 30, and go to about 15 minutes and 26 seconds in the lesson 30 video, that you should know exactly what question, what work to show, and how to do it. Does that make sense? Okay? So Do you feel like I've given you enough information to study for tonight? Okay, you know which questions on which reviews to go back and look at, study, figure out how to solve, right? What videos to go back and watch. I think that that ought to get you in terms of this test for tomorrow. Okay, all right. If you got any questions, get a hold of me.